revisit a derivative of the inverse function in a very quick way. And like I said to Mrs. Hersman, this may be the only point you get on the exam that you're going to get this point. And it's not that bad. It's actually kind of clever. So I have a graph here, and why don't I erase it and just, we did this yesterday. We got 1/5. But I want to start over with an easier way. Again, I'm going to look at a picture. And here is G, and here is G inverse. It won't take very long when you see what I'm going to do. And I'm going to put the point on the graph. The question for me is always, what is the point? I get the x's and y's mixed up, and I tend to use the wrong one. And it says, okay, girls, it says the graph here contains x equals 2. That's the inverse graph. So this x is 2. So on my original graph, which value is 2? The y. So you have to keep that relationship that the x and y is reversed. Well, I have a table. I know nothing about the inverse. But I have a table that says then the y on the G graph is 2, the x value is 1. So if that's the case, what's the x value here? 1. You got a point for that. That's kind of nice. You get a point for the ordered pair 2, 1. Yes? Mm-hmm. You're going to miss the best part of this, though. So now, the easy way to do this, okay, guys? And Adam, you probably should be taking some notes. The easy way to do this is to look at your graph here, and I'm going to put the point here. And if you can remember this, what's true about the derivatives of an inverse function and its original function? There is a relationship. They're reciprocals. Okay? Okay, Luke, question? These guys are reciprocals. So can I find the derivative of the G graph? So I want to find the derivative of G at what value? Not 2. At 1. So what's G prime of 1 if I go back to my table? That's 5. So then the derivative, I'm going to write it this way, too many primes and things, of G inverse is going to be the reciprocal. So it's 1/5. So if you can remember it that way, it's great. I actually prove it every time because I never remember it. Yeah, and that's great if you know that. Can you see that okay? Because we can close the blinds. So there's another problem, and this was out of the 2003 exam. They should have gotten a handout from me. I can't find my extras, so I made some extras, and I can make more extras. And it's problem number 27, and this was a separate sheet of paper, didn't get into your packet. Problem number 27, 2003. If you use this idea, but now you have to remember it's a reciprocal, but you know, we've been doing it so much, I bet you do. So I gotta find mine. It's a separate piece of paper.
The one that you printed out?
Yes. I don't have a lot. Is it this one? Oh, there it is. We did this yesterday, actually, didn't we? But I did it with the proof. Oh, you have it, right? Anybody? It's okay. I have a couple extras. So again, I'm going to draw a picture. Now, maybe by now, because I've taught this several times, I probably remember this. You know, what does x cubed plus x look like? It looks like this. But really, does it matter? No. So here's f. Here's the inverse, which is g. And I want, and now this is what I do is I analyze this. This is for g of x. The ordered pair is 2, 1. So for f of x, interesting, it's the same ordered pair. It's what? 1, 2. One of the first choice is using the wrong coordinate. So they're going to get you on that, because if you use the wrong coordinate, you say, oh, it's a. Well, it's not a. So this is f. I take the derivative of that. So f prime of x is equal to 3x squared plus 1. And I'm going to put in what? 1 or 2? 1. Because I'm going to find the slope on this graph, girls. And I'm going to find the slope on this graph. Remember, there's only 8 class periods left. After that, you're on your own. Okay, so f prime of 1 is equal to 3 plus 1, so that's 4. If you just look at the graph, you can see they're not the same. They are reciprocal. So what's the reciprocal for? 1/4. If you substitute in 2, girls, if you substitute in 2, you're going to get 1/13. So they're going to give you the wrong answer as a choice. And unfortunately, they give it to you as your first choice. When you take the multiple choice part of the exam, look through all the answers. There's 4. There's 13. Because sometimes they put the distractors in A, and then you never look for the right answer. Pardon?
Why do we use
Because I'm going to find the slope on this line, which is at 1, 2. So the slope is at 1 here, right? And then I just take the reciprocal of that. But I have to figure out what that point is. It's on the inverse function, not on f. What is the value of g prime of 2? That is this point on this graph, which is 2, 1. The slope at 2, 1 is the reciprocal of the slope of 1, 2. If you can remember that, you got it. It's a theorem. But if you can't remember it, you do what I did. You write the inverse function, you solve for x in terms of y, you take the derivative. And then you remember the y is the y value of the inverse function, which is this one. So see, it's still 1. Okay, we are going to do 2005. And I'm going to give you 2005. And then either we can do some more multiple choice or you can work. You get to sleep tomorrow.
Yes. I actually sleep tomorrow too.
I know.
Kidding, I'm going to be up in seconds.
No, you won't. Why do I have a bagel and oranges in here? And we're going to do number 2, and you need a calculator. Okay, does everybody have a 2005?
I got mine at my house.
I think I have one. I mean, I have this kind. You can try it. Good luck. They're nice, but you have to learn how to use them. Okay.
No idea.
Daniel, share with somebody. We have to give our calculators away because of all the testing that's going on. And, you know, we did the snow removal problem. We did the oil removal problem. And this is a sand removal problem. Well, right now, what they're doing down in Madeira Beach outside of Tampa, Florida, they're basically closing the beach for the whole summer, just north of where I am down there. And they are bringing sand in because the sand has been going away. And I can't remember how much sand, but it was a lot. So this is a real problem.
Sand goes away.
Yeah, it gets washed away with the storms. So they're bringing sand in to restore the beaches. The water just keeps rising. The sand beach is gone.
So just water now?
Yeah, I mean, here used to be, there's the water. Here are the buildings, and what's happened is this sand has been taken away, so now the water comes up there. Eventually, it could hurt the residences there. But you want a sand beach, at least I think you do. Okay. The tide, shh, you guys. The tide removes this. Artivan, let's get started. Tide removes sand from Sandy Point Beach at a rate modeled by this function. It's a calculator problem. A pumping station adds sand to the beach at a rate modeled by that one. That's exactly what they're going to be doing down on the beach in Florida. And they're going to be working 24/7. They're working at night as well. So it's going to be noisy for anybody who's down there. Not on my part of the beach, luckily, but it's close enough. Now, the units are cubic yards per hour. When they give me the units like that, I'm thinking maybe they're going to ask me for units. Yes, they do. Indicate units of measure. And T is measured in time from 0 to 6, which is hours. They don't really say that, but it is. Okay. A, how much sand will the tide remove from the beach during the 6-hour period? What do you have to do? You have to integrate. Remember, you were looking for total. Now, you guys, can you see this now? This is a calculator problem. You will integrate which one? This is the removal. For me, I got to do this. And this is the pumping station. So this is the adding. So think of S as sum. So it's R of T. Do you have to type that in? No. And we're going to go from where to where? 0 to 6. Okay. Now I got to bring my calculator up. If somebody doesn't have a calculator, if you want to come up here and do that, that's fine.
Searching for it for like an hour.
What?
2005.
I just gave it to you.
I know. No, that's not. I know.
So you should be ahead of me.
I have-
Adam, are you going to come up here and operate my calculator, or do you have a calculator? Okay. Now, why do I want you to do this? Preparing for the exam and waiting to the last minute to learn some of the nice things about your calculator is a little late. You need to be doing it now and practicing. So I don't remember what this was from, but I think that was from BC. So I'm going to put in to Y1. Now, do you want me to go back to classic print, or do you want me to stay
Where are
in?
we getting the sand from?
They truck it in. I don't know where they're going to get the sand.
From another beach.
Yes.
They put on another beach.
Costs a lot of money.
What happens?
It's probably out somewhere in the Atlantic that nobody goes to. I don't know where they get the sand. Maybe they didn't tell me where they were getting the sand. Okay. So, okay, guys. Do you want me to be in classic or pretty print? The nice thing about the pretty print, Artavan, is you know if you made a mistake, because when I hit enter, it's going to look just like this. I can switch back and forth. Now, see, I can barely see this. Now, I want the sign. What mode should I be in? Okay, I want 4 pi. I think I'm in radians. Where's pi? Is it above the caret here? Is that pi?
Yeah.
Thank you. Divided by 25. You're right, somewhere I have to have, oh, I couldn't see the T. So now I missed the T, but that's easy. I'm going to insert. And we're going to put in X, because I don't want to change all my coordinates. And if I press enter, it should come out and look nice. Well, it's not. I may not be in pretty print. I thought I was. Okay. And we want to integrate this from 0 to 6. So I'm going to quit. Remember where integrate is? Math 9. You know, I've just done it so many times, it's just easier. And this is 0. And I'm going to go up. I like to do my limits first. And then this is in Y1. And I might, on my paper, write that that's Y1. Now, you have to get your Y1s from the variables. You should have been doing this for all year. It's a function, and I want Y1. And I have to put in my X. When you do all of them, if you work on these, you're going to find that they're all kind of easy. You just have to do it. Cole, did you get that answer? Because I didn't check. Okay, so, guys, I can't see. I can't operate the smart board because I can't see it. but I can't see it. That's a little better. Okay, let's see how many points we get. I like to do it as we go. Except I forgot to do something. What else do I have to put on this problem?
Yards per hour.
It's, well, you guys, if you forget what the units are doing, this is cubic yards per hour, and then you're going to multiply it by the number of hours. So what's the result of the units?
Yards.
Cubic yards. And they're also asking how much sand. That's volume. Now, just because I was busy with the shade, I wouldn't have forgotten it.
They could put up sand.
No. Here's what you need. Now remember, this is a skeleton outline. That's a minimum. But no, they won't make you put sand in. So you want the integral. You get 1 point for that, 1 point for the 31.86. So now we got 2 points out of 9. The last part is the hardest one, but okay. Write the expression for y of t. Oh, by the way, I put this in y1. I'm going to put this one in y2. Is that okay? I just need to make sure that I know which one's which. It says I want the total number of cubic yards of sand at any time on the beach. So what's happening, how much sand do we start with?
2,500 cubic.
Okay, so for B, should be ahead of me actually, because remember, I'm not just doing the problem, I'm teaching it. So y of t is equal to 2,500, and then what happens? Some sand, well, yeah, I'm going to subtract the total amount that's subtracting, right?
Yeah.
So 0 to t of r of t, or x, however you want to do it. But we're also adding sand in, aren't we? Plus, we're adding from 0 to t, s of t. That's all I've asked for. Can we check it? Pardon?
Could you put the...
Yeah. And I would do s minus r personally. It doesn't matter, it's the same thing.
Oh, you can't do S minus R.
Sure, can't I? They use x's, but they are not going to get picky about your variables.
Why did they not do it like you?
They did.
Integrated?
Don't ask you to integrate it. They said write an
Why
expression.
did they not put from 0 to t on r?
They do. This parentheses means it works out r as well.
Oh.
Okay, so 1 point for getting the s minus r or the minus r plus s. I just did the way you guys told me, but it's right. Okay, Zach? 1 point for the limits. If you've got this problem done and you know it's right, move on to another problem. Don't waste your time. The more problems you do, the better off you are. Okay, guys? And then 1 point for that final answer. That's 5 points. Was that hard? I want you to start getting confidence. The more you do the problems, you're going to say, this isn't that bad. Also, things should be coming together for you. I don't know what the average is, but the averages usually aren't that high in AB. I'd have to go back and look. You guys can all look. You go to AP Central, and I think it's analysis or something. So, ready?
Yep.
Okay, C. Nick, what am I going to do? Find the rate at which the total amount of sand on the beach is changing when t is 4. What do they ask for? The rate is the, yep, it's the derivative. Slope, derivative, same thing. So I'm going to take the derivative of this. I don't even have to if I'm clever, because these are rates. But we'll go ahead and do this with respect to time. What's the derivative of my 2,500? 0. So that's y prime of t is 0 minus, what are you going to do with this? Plug t in for, well, I had x's there to be x's, but it's okay. R of t plus S of t. Or if you would prefer to see it this way, it doesn't matter. It's S of t minus R of t. Then you want to do R prime of 4. Now I'm going to show you an easy way to do this on your calculator, or Y prime of 4.
You're going to want to subtract S of t minus R.
No, this is a minus R. Just switch the order. Does it matter? Yes. I'm on C, sorry. No, I only wanted it 4. It says find the rate at which it's changing at 4. We're not doing an integral. We're doing a value, how fast the sand is changing. If the sand is positive, if this rate's positive, what does that tell you, Natalie? If the RDT is, or the YDT is positive, what's happening to the sand? More is coming in than going out. What if it's negative? More is going out than coming in, which is what is happening to the beach in Florida. If it's 0, it's an equilibrium, which is what you'd want. Doesn't always work that way. It depends on the storms. The storms take the sand away. It's the problem. Okay, so how do we do this on our calculator? Well, right now I've forgotten which one S is and which one R. So I'm going to go back up to my notes. S is in Y2, and this is in Y1. So you've got to get your calculator out now. Oops. Y2 minus Y1. And there are a couple ways to put this in your calculator. First I'll show you the direct way, and then I'll show you an even easier way. But you have to remember that's what you're doing. Okay. So you got your calculators? Okay, remember I have Y2 minus Y1. So I'm going to get bars. Now you have the new operating system. It's a lot easier to get Y2. Now, I want to evaluate this at what? No. At 4. Did you know you could do function notation on this? Minus. Now, for those who have the new operating system, those who don't, you have to do this the way I just did it. But if you have the new operating system, you press alpha and the trace button, and you can pick up Y1 quickly. I'll show you another way, though. You could go to the graphs. That takes longer. Whoops. Make sure I got the right minus. I bet I didn't.
Oh, God.
Oh, you know what? I don't have the other one in. That would do it. What is the other one? Now, I need my parentheses. Otherwise, I'm not going to get this correct. Over what?
1 plus 3.
1 plus 3t? What? Yeah, it does help with the function, doesn't it? Now I can just press enter again. It's okay. There it is. Okay? Now there's another way to do this. I'm going to clear this. And what I'm going to do is I'm going to put 4 in for x. I'm going to put 4 and I'm going to store it. Or as Mrs. Hersman says, she's going to stow it. Well, if you're in a boat, you stow things. Right? Store it in x. A nice little trick. I can store it anywhere I want, by the way. But I'm going to put it in for x. And, shh, you guys, Artavan, I bet you don't know this. If I don't put y1 of 4, it's always y1 of whatever's in x. So all I have to do is go to, I'm going to get my y values this way because it's easy. It's y2 I want first. This is why you want the new operating system. I don't have to say 4, but I have to have stored it first. That's the dangerous thing about this.
Why did I get...
It's up there on the board, but I'll get another one. I can just do it that way. But I have to have stored it first.
Well, that's...
Because you didn't have your parentheses in Y2 correctly.
Oh. Okay.
Only 1 point for that part. So here's the answer. Yes.
So, would it be the same units?
Are they asking me for units?
Per minute?
No, didn't ask me for units, but it's a rate, so it's cubic yards per hour. If you think about it in terms of real context and what's really happening, it's not that bad. Because you just think everything you learn in science, it's all going to work here. Okay, so let's see. I'm going to guess it's 2 points.
I guess 3.
Well, it's 1 point.
1 point.
Now, they put the units in, didn't ask for units, Adam, so I don't care about the units. So I can put them in or not. Now, would you get a point for just having the answer? No. No. It's negative 1.908. I think, no, you have to show the work. You have to show at least something like this. And if you do the wrong order, you know you're going to have the wrong answer. If you mess up your parentheses, you're going to have the wrong answer. Now, what they've been doing in recent years is they would have you do that, and then they would have you interpret your result. What does that mean? If the difference in the sand is negative, it's losing sand at a rate of almost 2 cubic feet per hour. Yes? Don't round at all, just truncate. You can round if you want. That's why there's 2 answers here. Personally, I wouldn't do that at all. I would write all the numbers down, because if you go to 2 places, you will not get the point. At least 3, so I give all of them. But here's the best part about it is as a reader, I'm only going to look at the first 3. These could be all 9s, and I don't care if it's wrong. Not going to look at it. Okay? Now, pardon? I don't know. I have the numbers. I can bring them in. In my classes, in rehearsals in my classes, our average, I believe, was about a 4. There are people who get 1s and 2s. By the way, I want you to realize that even if you have an A in my class, that means absolutely nothing about how you're going to do on the exam. How you do on the exam, Adam, how you do on the exam depends on you doing problems and studying for this exam. Going in cold without doing anything, you're probably looking at a 1 or 2. It's a time test. If it wasn't timed, it'd be different. Say that again? Yes. Yes. And by the way, Artavan, the question is, have students that have gotten C's in my class, Adam, have they gotten 5s? Yes, they have. They came to study sessions, they did the work, they prepared, and they got 5s. Sometimes we're in shock.
We got 6.
Nobody gets 6, unless you take an IB. Okay, let's do the last part.
So what about the purpose?
No. Nobody's ever had a perfect score, because if they did, that would be news.
I'd be what?
It would be news. You'd be famous if you got a perfect score. Okay. I think the people who could get perfect scores plan on bypass this whole thing. They're so far ahead of us.
So, you can get a 0.
Okay, shh. I don't believe so. The lowest score you can get is a 1.
I think if you don't complete certain parts, really?
I see a lot of blank tests.
Like, if you don't complete anything, you still get 1. Like, if I look for text, it's like, well, you didn't do anything. Yeah.
No, maybe, yeah, maybe you didn't do anything.
They're all like English, that's like all different languages.
I don't know. I don't know. I've never seen any class including a 0. Okay, guys. Let's get this done. Now, I'm looking here and read the last part. Put that away, please. Guys, how many class periods? Don't waste my time.
Is it 8 including this one?
Yes.
So there's only 7 after this one.
After this one, yeah. Okay, guys. Shh. If you want to have your conversations, just go out the door. For t between 0 and 6, what time is the amount of sand on the beach a minimum, and what is the minimum value? Circle that. Pardon? And then it says justify your answer. You always have to justify your answer. I don't care what if they don't say it, you still have to justify your answer. I want an absolute minimum, and I have a closed interval. Is the function continuous? So why not use the max-min existence theorem? Now I want the total amount of the sand to be a minimum. So I want which function?
What F prime?
Y. Well, y of t, because that's the total amount of sand on the beach at any given time. So I want y of t to be a minimum. So this is d. I hope you get this because this is easy. Where are your critical points, Luke? Guys, go. I'm not joking. If you want your conversations, go out there. I'm not joking at all. I want this to be a good video, and now it's not. This is taking way too long. Okay. Now, how do you know where minimum values occur? Artavan?
Yeah.
Where are the critical points? The end points.
F prime is.
F prime is 0, and F prime is undefined. And honestly, I don't see many of those in these problems because they're like real problems. So I want the derivative to be 0, and so I'm going to take y of t, and I have to find where the derivative is 0. Did I do that already? No, I don't think I did. So what was y of t? Well, that's y prime of t.
Y prime of t is R.
I got it for you.
S of t minus r of t, right? So I'm going to get this table set up. I've got 3 places. I'll try being fancy here. Except where is it? It's only promises up here. Okay, where are the 3 places? Okay, so I have x and I have y of t. So I have 0, 6, and I don't know what that point is yet. We could find y of 0. And remember what y of t was. It was 2500 plus 0 to t, which one's bigger? S minus 0 to t of r. So what's that? It's 2500. Because the integral from 0 to 0 is 0. Okay, we need to find out where S of t minus R of t is 0. Mrs. Hersman likes to find where they intersect. I like to find the zeros. And the reason being is that if you graph 3 to the x and x to the third, if you try to see where they're equal, you will not be able to see that. I don't care how many times you zoom fit, you're not going to be able to see where they intersect because they're so close together. You really have to play with the window. If I go for zeros, I don't have to do anything with the window. So I'm going to do S of t minus R of t. And I'll put that in y3. Okay, wait. Does it matter which one goes first? No. Oh, I got to get my calculator. And then we're gonna store that value. You have to write the whole thing down, that whole number. Okay, so I'm going to do, and there's a solve button on here as well. I don't know why that does that. There we go. So y equals, I'm going to turn this off. You guys know how to turn these off? Because I don't want to see that graph. And I'm going to turn this one off. Now, I suppose, ZoomFit probably works 95% of the time on any of these problems because they're more like real-life problems. And they're not going to give you ones so it's hard to find the intersection point. So you could do that. So I'm going to do y1 minus y2. So I'm going to be quick about this. I'm going to go alpha. You guys should be quick with how you do it. But if you have the new operating system, this is so much nicer.
Why are we turning it off?
I don't want to see those graphs. I just want to see my 0. What's my domain?
0 to 6.
0 to 6. So I'm going to make this 0. And I'm going to make this 6. And the y values are okay unless it's, I think it'll be clear. We'll find out. Okay, it's not exactly clear. But why do I not have to worry about, I don't think this is a point there. So let's go into y equals, I want to change this as well. I don't want to a very thick line like I'm getting. That's part of the problem. You should be doing this with me. Does it matter which way it is? No. Because I'm just looking for where it's 0. What has to happen? It also has to change signs. So I don't care if it's plus, minus, minus, plus. I'm just looking for that point where it changes sign. Because I'm going to evaluate my function there. Pardon?
What's my y max?
I'm at -3 to 3, but it doesn't really matter. That should be. I still don't know if that's hitting there. But it doesn't change sign. So if I want to make sure that it's going to work nicely, now I'm going to press on to stop it from graphing. And I'm going to make this -1 to 1. And actually, in this case, the intersect one works a little bit better, because I've seen the graph. There. Now I can see it's not 0 there, but it is 0 right there. Remember how to find the zeros?
Yeah.
Second, calculate. And I just want a 0. So when I do a 0, it's, I don't know, it's a horse apiece.
I got it.
Okay, so I'm going to type in, let's see, 1, 2, 3, let's type in 4. And the right bound, let's type in 6. As long as you're on your graph, you're okay. And the guess is just looking in case there are 2 possibilities, but there aren't. There's just the 1, and there it is. 5.1178, whatever. Okay. You just do it on your calculator. Now I have to evaluate y of t. Right? So I'm going to quit. Now, you guys, do you realize that if I press X here, I'm going to clear the screen? What's in X now? What I just had. And the Y is also there, in case I do that. But let's store this. And I usually use A. Go to alpha A. Because once we put it into A, I can see it. Nobody can mess with it except for me. If I go and graph something later on, X will change. So if I need that value for something else, I really want to keep it safe. So I'm going to put it into A. And now all I have to do is find Y of A.
Quick question.
Yeah.
Whenever they're for CT, you have to put the entire value? Or do you
Yes. The question is, if this is my critical point, I have to have the entire value. I have to work with that value. So that's another reason why I want to store it, because I don't want to type that number in, because I'll probably do it wrong. Okay, so now I need y of t, which is 2,500 plus, actually I could put this into something, well, I could put this into the y's. And then I want the integral, right? So it's going to be math 9, and we're going to go 0, and we're going to go to what value here? What did I call it? A, right? Whoops. Well, it still works. Okay, alpha A. Where's that point? And then we're going to put in, that was the plus, was S of t. S of t, was that Y2? I think it was. Alpha. And I would be able to see that. And then I would pick up Y2. And then you're going to put in an X, because that's all we have here are X's. Whoops. And then we're going to put minus. And this takes time. That's why you want to do this. I'm faster on a calculator because this is really slow on this calculator.
So what's the point of
Because we're going to integrate to that point. We want to find, we're just evaluating y there. And this is alpha A. That's my critical point. Where will my minimum or maximum occur?
oh, so you're okay.
Only place it can occur is at the endpoints or when the derivative is 0. I think I have to worry about a sign change, honestly, because it doesn't matter. And this is X. Okay, 2492. That's lower than 0, isn't it? How do we do 6? Well, what I'm going to do is do second enter, and that, because that's what most of you are going to do. And then all you have to do is arrow back in here and change that A to a 6. Oh wait, I did that one. I gotta get further back.
For B?
Takes,
2,500.
I got 2,500 if I do 0 to 0. I don't know what I'm gonna get. I don't know what I'm gonna get for 6. No, I got 2,492.
I got 2,500.
Then I want to see what you did. And for 6, I get 2,493. Okay, now I can get rid of my calculator. I'm going to come and look at yours. Okay, so at A, and I've told the reader this is A. So I don't have to write that number in there. At A, I get 2,493 to 3 decimal places. And at 6, I got 2,492.
It's the other way around. It's the other way around, yeah.
Is it?
Yep.
Oh, you're right. Darn. This is 2,493. But don't throw out the endpoints because it happens a lot. And this is 2,492.369. Which one's the minimum? A. Now, what's the question asked? So I get all my points. It says, what time do you get the minimum? Well, the minimum occurs at what? At T equals 5.117 hours and is 2,492.369 cubic, what was it? Yards. I need all that to get all the points. So what they're doing here, yes, at 6 hours, it's actually coming back up. So that's good. But before that, it's not. Okay, so let's check my answers. And they did a little table as well. It's 3 points. Just setting this equal to 0 gives you the 0, gives you a point. Finding the 5.117 value, right there, that gives you a point. And forget the rest of the max min existence theorem. It's only 1 point for all the rest of that. All the rest of that. So the 9th point, when you're looking for, if you're looking at your clock and say, hey, I don't have much time left. I've done this. I found this. I don't have time to figure out which one it is. It's only a point. If you got 8 out of 9, you're doing awesome. No. But how do you do better? Do problems. Ooh, it is 11 problems. They're equal. They weigh the multiple choice. Can I see your calculator? Oh, let me pause it. Stop this. Now you could do